thinking about it. Okay, there's our normal pictures of stuff, and we are recording. Welcome to class if you are connecting to us through the video. Okay, so what we're going to do is we're going to look at the derivative and the second derivative and kind of analytically be able to describe things about the graph. Okay, so it's, again, if our only goal is to graph, we're usually going to use technology. So this is about understanding the relationship between the derivatives and what we see in the graph. All right, can I get these buttons to work? Next. Okay, so a couple things. When we think about the first derivative, right, when it's positive, we know that the curve is sloping upward or rising. When it's negative, it's falling. When it's zero, it's possibly, oops, a maximum or minimum. So one thing we haven't talked about much is what about the second derivative? So this isn't anything you have. We're just kind of walking through. If you are watching this, this is not on any handout that I'm handing out. So it's just for conversation and discussion purposes. So we haven't talked a lot about the term concave, right? So when we have a second derivative is positive, that's telling us that the slope is accelerating in a sense that it's curving up, where it's increasing. The slope is increasing up, and so the curve is concave up. So this top right picture where you can kind of see the parabola, when your double prime, when your second derivative is positive, it's going to have this concave up feature to it. Okay, and likewise, if the second derivative is negative, it's concave down. So the difference here, though, when it's zero, right, what that means is it's changing from one to the other. Do we have that in here? Yeah. So when it's zero, if you look at the bottom right graph, this part on the left is what? Is it concave up or down? Right here is concave down. And this piece is concave up. Concave up. So when it's changing from concave down to concave up, you can see that here the slope is getting smaller and smaller and smaller, and now the slope's getting bigger and bigger and bigger. So it's kind of an inflection. That's called an inflection point, possibly. Or it is on that occasion. So let's look at an example. This is a polynomial. It's third degree. We have the factored form on the right. And so if we look at where it's zero, we have these two places. Now we're going to go through the first and second derivative and see what that tells us. So when we take the first derivative, we get this parabola, 3x squared minus 6x. And we find out when is that equal to 0. Okay, so what values of x would that be equal to 0? This is 0. And if we factor out 3x, what would be the term that we have left? X minus 2. So at 0 and, right. So when we factor that, we get down to 0 and 2. Those are our places where the derivative is 0. So that's a possible what? Thinking back. The slope 0. What's that mean? Yeah, it could be a maximum or a minimum. And we get 2 of those, which makes sense in terms of a third degree, that there should be one less as the maximum number of extrema. So, right, sometimes you can use a chart or a number line, some way to kind of keep track of things. So we have y prime is 0 in these two places, at 0 and 2. And then let's investigate what the derivative is to the left and to the right. So we're choosing 1 because it's where? In between them. So it's negative there, meaning that the function is what? What's happening to the function there? It's decreasing. Yep. And then if we look on the other side, we see that it's positive, which means it's increasing. So it increases to 0, then the slope is 0, then it decreases. So that's telling us that we can also check the last one and see that it's positive as well. So it increases, then it's 0, then it decreases. And then as it decreases, it hits 0 again, then it increases again. So if we think about that, it's going to be a maximum at 0, because that's where the high point of the graph. And then at 2, it's going to be a minimum, because it decreases until it hits that, and then it increases. Let's pause right here